Let's discuss part 2 of AC bridges. We are going to start measurement of inductance. Okay, we are having 4 bridges for this purpose. We are having Maxwell's bridge, which is used for measuring coil of medium quality factor. Quality factor between 1 and 10 is considered medium. Then we have Haze bridge. It is used for measuring coils of high quality factor greater than 10. Anderson's bridge is for measuring low quality factor less than 1. Then we have Owen's bridge, which does not only measure self-inductance but also the incremental inductance. Okay, let's get started with the Maxwell's bridge. Here what we are doing is we are comparing with variable self-inductance. Okay, this is your circuit for the Maxwell's bridge, and this is your variable self-inductance. Okay, and this is your unknown inductance. Now what we are doing is, as you know, this is variable in nature. We are varying this to such a level that the deflection across this detector is null. Only and only then we can say that this arm impedance is equal to this arm's impedance, means this value is equal to this value. Hence your unknown value is defined in terms of known value. Okay, so this is what we are going for. This is your circuit and this is your phasor diagram. Keep in mind that you have to practice both circuit diagram and phasor diagrams thoroughly of each and every bridge. Okay, now at balanced condition, okay, when the bridge is balanced, your unknown R is given by this particular formula. This unknown R is given by this formula, and your unknown element this is given by this particular formula. Then we have these conditions at balance. Okay, now we are moving on to Maxwell's inductance capacitance bridge. Okay, here what we are doing is we are finding unknown inductance from known capacitance, and when you balance the bridge, okay, when you balance the particular bridge, your unknown resistance is given by this and your unknown inductance is given by this. Okay, and the circuit for this bridge is, here you can see, inductance capacitance. Okay, we are using a capacitor to find your unknown inductance over here. This is what we are going for at balanced condition. So is the case. Okay, at balanced condition, your value of this unknown R and unknown L is given by these formulas. Unknown R is given by this and unknown L is given by this over here. Now we are talking about quality factor. The quality factor is given by this particular formula over here. Okay, now we are having the phasor diagram. Okay, this is the phasor diagram of this particular circuit. Okay, the advantages of using this particular bridge is Maxwell's inductance capacitance bridge. Okay, the advantages we have is that R4 and C4 are chosen variables. Okay, if you choose this R4 and C4, if you choose these are the variables for balancing this particular bridge, then you can make the bridge balance faster. Okay, because R1 and L1 become independent. See, your R1 and L1 do not depend on this particular R. Okay, so the bridge balancing becomes faster. In part 1 we have studied, if you take the common variable, then the bridge takes more time in balancing, but you take something which is not common. Okay, if this particular element is not common to other branches, then your bridge balances faster. Okay, then we have simple expressions. As you can see, quality factor expression, rather simple. We have R, unknown R. This expression is also simple. This expression is also simple. Okay, then we have measuring wide frequency of audio and power. Okay, you can measure a wide frequency range with this particular method. Now we have disadvantages of this. Not for high quality factor. Okay, this method is not suitable for high quality factor measurement of inductance. Okay, and it is not good for low quality factor also because of sliding balance. Okay, sliding balance means the bridge will take more time to get balanced. Okay, so you can measure only medium quality factor coils only. Okay, then we have variable standard capacitor is expensive. Okay, this capacitor over here is rather expensive. These are the some disadvantages. Now we are moving on to Haze Bridge. Okay, which is actually modified Maxwell's bridge. Okay, as you can see, this is your Haze Bridge. Okay, what we are doing here is comparing it with Maxwell's. Here you see it is Maxwell's bridge but in a modified way. Here you see these R and C are in parallel. here they are in series. Okay, it is the modified form of this Maxwell's inductance capacitance bridge. The only difference it holds is here in inductance capacitance bridge these two are in parallel, but here they happen to be in series. Okay, we are doing the same thing over here. This is the desired Phasor diagram over here. Now the quality factor is given by this particular formula, and at balanced condition your unknown resistance over here, this unknown resistance is given by this formula or this formula. As per the data given in the question, you can choose either of the formula. Then unknown L is given by this formula or this formula, as the case may be given in the question. Okay, this is all for part 2.